Good morning, everybody. Let's try it again. Good morning, everybody. I know it's Friday, it's early. Thank you, everybody, for being here. I appreciate it. Thank you to GPSD for hosting us once again. I've got my good friend Nick here with Huber here today. He's going to do two quick presentation here. One is going to be on some strain press, and the other one is going to be on some dewatering equipment. For those of you that don't know me, my name is Hunter. I'm with Gasvoda and Associates. I've been here about 11 years or so. I handle this territory with my partner Ryan Gasvoda. Some of you might know him as well. Without further ado, I don't want to steal any of Nick's thunder. I'm going to pass it over to him here. If you guys have any questions, please feel free to just jump in. We'll keep it very informal. We're pretty laid back guys. So yeah, without further ado, Nick, it's all yours.
Yeah, thanks. Like Hunter mentioned, my name is Nick Janis. I live just north of Milwaukee, up in Wisconsin, so just a quick 4-hour drive. I've been with Huber for about a year now. However, I've been in the industry for about 15 years. I'm a civil engineer, so I've got a real technical background, and I understand the equipment pretty well. So today we're going to be talking about sludge and screening and thickening and dewatering, so super exciting on a Friday morning. But it's going to be pretty interesting because there's a lot of pretty neat technologies that are out there, not just on the Huber side, but across the entire industry. There's a lot of companies out there that do these pieces of equipment, and it can really make your lives easier. It can make operations much better at plants, and overall it just can really improve the plants quite a bit here. So we're going to try really hard to make this as not salesy as possible, so I apologize. It's really tough to edit every single slide over 2 hours worth of presentations to remove every single logo, and I'm doing my best to not make it that way, and I'll try to keep it as general as possible. So I apologize in advance if it feels slightly salesy at times, but we're going to jump right in here. And the first presentation, as Hunter mentioned, we're going to be talking about strain presses. And strain press, if you're not familiar with that, we're basically taking sludge or scum that you remove from primary clarifiers, secondary clarifiers, digesters, or even like a sludge hauler acceptance station that you have on your facility. And we're going to be trying to remove inorganics from that sludge. So there might be plastics in it. There might be rags and fiber and hair. We'll dive into those details a little bit more here. But essentially what we're doing is we're trying to remove inorganics from the wastewater. So did you?
Quick question before we get started. Is anybody familiar with this technology or use any of it at their plant, maybe currently or previously in a past life? No? Okay, great. Just a quick question.
Yep. And also, like Hunter mentioned, please, if you have a question, feel free to raise your hand, or if you need something clarified further, it's not going to hurt my feelings if you guys interrupt me or let me know you have an additional question, so don't be shy. All right, so a couple of the overviews of the topics we're going to be talking about here is why do we screen sludge in the first place? Why not just push it right to a digester and let it cook for a while? What benefits are we going to be seeing once we do this cleaning of the sludge? Mechanically, how do these sludge systems actually work, both mechanically as well as for adding a polymer or some other chemical? We're really going to dig into how they work on that physical side of things, give a little bit of the background on those technologies. What parts of the plant are these sludge screens beneficial? So is it better to put them in the front, in the back, in front of a digester, or after a digester? We'll talk about exactly where they go and where the best places to locate them. We'll take a look at the different options that are out there on the market and some of the advantages of some over the others. And then lastly, we'll talk about maintenance, which is what a lot of operators are most interested in. How often do we have to have our hands on this thing, and how much of a pain in the neck is it going to be to operate at our plant? So we'll talk a little bit about what needs to be replaced and what needs to be worked on maybe a monthly or an annual basis. So starting off at the beginning here, why do we screen sludge? So depending on the plant, some plants have very, very good headworks facilities, and they can remove a lot of those inorganics that are coming in. Like I said, plastics, rags, grit, a lot of these inorganics that are generally not digested or treated by the biological process in the plant. So that's really the main thing that we're trying to take out. And when we take that out, that means that we're not going to be putting that into our digesters, which have kind of a precious amount of space and volume. We don't want to be filling that up with a lot of these kind of garbage pieces of inorganic material. So trying really hard to reduce the amount of clean out and the amount of unwanted material that we accumulate in our digesters. And then, of course, on the maintenance side of things, we really want to protect our downstream equipment. So things like pumps and valves, and if you have clarifiers with arms and mechanisms, we just don't want those pieces of equipment to get snagged up with rags and hair and fibers. So we're really just trying to screen a lot of that stuff out and protect our equipment downstream. Safety-wise, I know that seems like it's maybe overreacting a little bit, but we are trying to avoid putting operators down into these digesters and having to maybe hire divers. You'll see some pictures, some plants, they'll actually hire divers to go down into these digesters with full suits on, and that can be very dangerous from a confined space aspect. Also, cost-wise, it can be extremely expensive to take digesters down and totally remove all the solids, go in there and scrub and remove all the rags and plastics that accumulate in there. So many plants that we talk to, they're talking hundreds of thousands of dollars over years when you talk about removing inorganics from those digesters and other pumps and valves around the plant. It can be very, very costly on an annual basis. So if you can remove these items up front, you really reduce those costs and kind of the pain in the neck that you guys have to deal with long term. So here's a kind of a photo of an operator here. He's working on a pump, and you can see he's pulling out rags and all kinds of other debris that's not only causing downtime for the plant, but it's probably costing him hours and hours worth of messing around and cleaning up the pieces of equipment. So, like I mentioned, here's a picture of a diver here going into an enclosed digester where he has to go down and either fix a valve or fix a pump that might be in there, and they don't want to take the entire thing down. These guys are very expensive on an hourly basis. So just, again, trying to save money and save the plant a lot of these headaches that they typically deal with. So in addition to removing these from the water and the sludge that you're putting into your digesters, a lot of people don't realize that a lot of these inorganics will take up precious volume of those digesters as well. So if you have rags and plastics and other items in that water, if it represents 10 or 20% of your total volume of your sludge, think about a digester that maybe has 5 or 10 million gallons worth of sludge in there. If you are losing 10 or 20% of that due to rags and plastics and hairs and stuff that accumulates in these big islands on the inside of digesters, you're reducing that volume of the digester. And you're also reducing the amount of volume of sludge that is producing gas if you are producing gas and having cogeneration on site. So we are also increasing the digester volume by removing a lot of these screenings. There are some other technologies that are out there on the market that do more of a grinding than a screening and removing. So their theory is, rather than messing around with screening the sludge and taking the solids out and storing them into a dumpster, let's just grind them up into smaller pieces, still stick it in the digester, and then you won't have to worry about pumps that are plugging or valves that are getting snagged. That's true in terms of the maintenance side of things, that it improves maintenance, but it still doesn't fix the other problems, which is the volume, if you are putting sludge out in farmers' fields, a lot of times they don't like plastics and rags and wipes and all these other things going onto fields. So it solves about 25% of the problem, but the other 75% of the problem is still there. They're just breaking it up into a smaller chunk and throwing it into the digester. So grinders work to solve some of the problems, but not all the problems. But yeah, you still are pushing a lot of that stuff through your pipes and into valves and into pumps, and yeah, it's just not generally the best solution to grind. So on this image here of the plant, you can see there's lots of different sources of the sludge. Some plants accept manure, they accept biosolids, depending on if there's kind of a regionalization of a biosolids facility with a number of communities. Some plants they accept food waste from haulers, so whether they're taking grease traps that are being cleaned out, or if they have industrial customers in town that are maybe food producers or big factories close by that push a lot of food waste to their plant, as well as some other industrial organic suppliers of the sludge that comes into the plants. They're all eventually going into your digestion, whether it's anaerobic or aerobic, to produce biogas or to digest into other products. But again, the main purpose here is let's clean that sludge up and let's get a lot of that really nasty stuff out of there that's not going to break down and it's just going to cause problems downstream. So, did you have a comment?
Any questions so far?
So this is kind of what a grinder looks like here. You have bigger items that are coming in and they get chopped up into smaller items. And again, they work okay. They will solve some of the problems, but they just don't remove all the problems that you're going to possibly deal with. This is just an example. You'll see many examples here as we go through the presentation here, but this is what the screenings look like. You're removing a lot of the hair and fibers and rags and plastics. So typically this is what you see coming out of the backside of a sludge strain press, which again, this stuff is not going to break down in a digester. It's just going to kind of sit in there and eventually get either pumped out or put onto farmers' fields, which again, they typically don't like to see that stuff kind of plugging up their fields. Okay, so what do these things actually look like now that we kind of understand what we're trying to do here? So the strain press, this is a horizontal pressurized cylinder. So it's not like a regular screen where that sludge is going in and you're using gravity to squeeze out the water. This is actually a true pressurized vessel. So water is coming in on this front pipe, kind of coming up vertically. It goes into the front part of the cylinder, and on the inside of that cylinder, there's a large auger that is kind of turning and pushing and squeezing those screenings, in this case from left to right. And when I say pressurize, that pressure is being generated by that motor on the end, which is pushing and squeezing those solids from the left to the right direction. You'll notice that the basket around that auger, it starts out wide and it tapers down to a smaller diameter, and then it has a consistent diameter on the second half of that press. And you can also see that the auger, the actual, the flights on the inside, or the, I'm not sure what you would call that on the inside, but those get spaced out more and more as the sludge gets more compressed and under higher pressure towards the end there. So the basket changes as well as the inside of the auger. So as the screenings come in, they're still generally like 1 to 5% solids concentration when you talk about those inorganics. So they come in a pretty liquid state. By the time it makes its way across that screen, it gets more and more compressed, which means that those inorganics get squeezed more and more and more, and that wastewater gets pushed out on the side of those baskets. And by the time it gets to the very end, they're actually pretty compacted and pretty dewatered. So that picture I showed before is an example of what it looks like on the backside. On the backside of that screen, you'll notice that there's a cone, and that cone has a pressure that's constantly pushed against the end of that screen using 2 pneumatic cylinders, and that just provides a nice constant squeezing pressure at the very end to squeeze those last little bits of water out and sludge out. And then those screened sludge solids coming out the backside, they squeeze out of that cone and they simply drop down into either a dumpster. If you have a conveyor with multiple machines, it'll drop down onto there, where it'll be taken away. Or if you have a smaller plant where you only have a single or maybe 2 of these units, you can do a continuous bagging system on there to control the odors and flies and other issues that arise when you have this pretty stinky stuff at the end of the process. But we can customize whatever is needed. So as the sludge is going in and the liquid part of it is getting squeezed out of that basket, you'll see it gets collected in that pressurized chamber and it goes down through the screened sludge out pipe right here. So that is very, very clean sludge, and it shouldn't have much fiber or rags or inorganics at all. It's pretty remarkable how clean it gets, how clean it gets as it goes through that basket. Any questions on the construction of this? This is usually where a couple questions pop up on.
That makes sense how it works. That's part of like
How does it differentiate between like just some grit or like some organics that are in the sludge? How does it?
So if it's small enough, like a real fine grit or some organics, that will simply just squeeze right out of that mesh basket all the way around. You do get some that will be retained in the screenings that come out of the basket at the very end. If you look at those pictures, you can still see it's pretty dirty. We don't have like a washer that's doing a real thorough washing of those screenings, but the majority of it, there's a lot of pressure that's squeezing. I think it's like 25 to 45 PSI that we're putting on the inside of that basket. So you're really squeezing out the water and the sludge, which has the organics and slight amounts of grit in it. So
You're collecting what squeezes out.
exactly, yep. Well, yeah, we're retaining what is squeezing out, and the liquid is being pushed out of that basket. So imagine, this is kind of a gross way of thinking about it, but imagine you have like a big pile of wet rags that's all nasty and messy, just squeezing the heck out of it where all that water gets squeezed out, and what's left over is basically all those pretty wet but mostly squeezed out rags. So
And when he says rags, he means rags. He's from Wisconsin. We'll let it slide. It's all right.
The speed of the auger on the inside here, I forgot to mention, this is all driven off of the 2 pressure sensors that you see up there on the screen. So if you have a thinner sludge that's coming in and you're not squeezing as much stuff out, it might speed it up in order to push that liquid through a little bit faster. If you have a big slug of inorganics and stringy stuff that's coming in and it needs to slow down and just slowly apply that pressure, it'll see the differential between those pressure meters and it'll slow down that auger in order to real slowly just kind of push it out. So that's all automated. It's all controlled by the control system, and that motor will automatically adjust the speed based on a VFD. So it's very, very hands-off, and basically when you turn it on, it runs itself and it'll adjust itself up and down depending on what's coming in and what's hitting it. Sure. So we rate our systems based on, we call it a throughput, and we base it on a gallons per minute. So I'll show you, we've got a couple of different options here, but again, not to be on the salesy side of things, but at Huber we have 2 different sizes, and our max, the largest size we have, we can treat, I believe it's close to 1,000 GPM. And on the smaller end of things, we can do like 300 to 400 GPM. So anything greater than that, you just have multiple units that you, yep. Good question. All right, again, last chance. Any questions on this slide here before we keep going? Turn the lights off? Good question. I know it's a little faded. Yeah. So I've got another slide that shows where it can be used, but you can use it anywhere from, if you just have a primary clarifier, you can stick these right after a primary clarifier. If you have everything that's going to a single digester, you can put that in that location. So it really depends on what the plant has, where their problems are kind of starting. And then you can also put this at the location where you are maybe accepting sludge hauling that's coming in. So if you know you have sludge haulers bringing in grease trap, pretty nasty, sticky stuff that has forks, napkins, stuff that you see from restaurants, you can stick that right at the headworks of a plant too. So it's pretty versatile. You can put it wherever the problems are. So is that any better with the lighting? Maybe a little bit? Okay, cool. Oh, now this thing stopped working. Oh. Uh-oh.
Take a 5-minute break. Give me a minute.
While that's happening, do you guys have any other questions or comments? Have you guys seen anything similar to this in the past? No? You want to talk about the Bears? Nick, you want to talk about the Bears?
No.
Okay.
Bring any cheese?
No, but if you want, I can probably send some down here.
Next time, yeah.
No. So in theory, you're kind of doing the same thing. You're taking inorganics out of the water, but this is mainly designed for sludge that is somewhat thickened to like 1 to 3%. So what you're pulling off of the bottom of your primary clarifiers, your secondary clarifiers, and if you are if you know that you're going to be sending material directly to a digester, it's best to put it in that location where a lot of the stuff that's coming into headworks, it could be potentially large, and sometimes headworks of facilities, they might see chunks of 2x4 coming in, or maybe even other sort of bigger inorganics, but by the time you get to the primary clarifier, the secondary clarifier, you're not dealing with too many bigger inorganics. It's more just stringy, plasticky stuff. So.
So yeah, good.
Yep, I think we're back here. Thanks. Oh, it doesn't like that slide. So I think we were, yeah, number 6. Huh. Maybe we skip that slide. Pardon me? I think 6 is. Yeah, we can probably.
If you want to do the YouTube slide on that. Well, you just would be on that screen, so that people on YouTube can see it there.
They're not gonna be able to see it now. YouTube will see it, but
Can you go backwards and see what happens? On your presenter?
Oh, go backwards.
you have that next slide on YouTube, correct?
That's,
That's the one that you need to play and it shows how it works.
yeah, number 6.
Can we just skip and go to YouTube, Mark?
Let's see if this works. I thought that one message about enabling content was all they had to do.
Huh.
This doesn't like it for some reason right now.
This computer is connected to the internet, right? So maybe we could just go directly to YouTube and should be able to pull up that.
Does that have the, is that the YouTube videos?
It should be when you're in the PowerPoint presenting mode, it'll play it. But if you can, on a web browser, just go to YouTube and. You can just do a search. Just type in Huber strain press. There we go. Yep. All right, here we go. We're going to try to.
Let me put your slide on 7.
Okay. Okay.
Our YouTube viewers, should I just leave it on that screen and let him?
I'll just stay in here. I'll just stay in here. We'll put it on there after we. Okay, you ready?
Yeah. All right, so this is what we were trying to show in that slide, but there's a little bit of technical difficulties. So this is how the strain press works here. So the dirty sludge is coming in on the left. It's going into the auger, like I mentioned. We have a pressure on the left side coming in, which is kind of the baseline, and then we have a pressure sensor on the inside of that chamber, so it can truly measure what the difference is, and it can speed up or slow down, like I mentioned. Now that sludge is going from left to right, and as it's going from left to right, it's getting thicker and thicker and more compressed. And you can see there it's being pressed, continually pressed against that basket. All right, and then on the very end of that machine, you can see that's that cone-shaped compression on the backside here. And you have the pneumatic cylinders that are pushing against that to keep a nice constant pressure on that. We call it a plug of screenings. And that's important to get that final dewatering and that final pressing. And then as those screenings get to the end, they literally squeeze out around that cone-shaped compression on the backside there. As I mentioned, you can either do a continuous bagging system to collect those solids, or they can just drop through a chute down to a dumpster below or to a conveyor. But that's essentially how that part of the system works. I didn't get to this point yet, but we're kind of fast forwarding here on the video. To do maintenance, it's relatively simple. We've designed it to split right in the middle. You'll see there's a flange on the middle of the machine, which you just take the bolts off. It's real easy. There's a gasket in there. And then the second half of the machine is on casters. So once you break that flange, you can separate that second part of the machine. And then there are the two baskets on the inside. There's the kind of cone-shaped basket and the cone-shaped auger, which you can replace real easily all by hand. You don't have to have a hoist or a lift or anything. And then similarly on the other side, you have a constant diameter auger. And then you also have that basket as well. So it's really four main parts on the inside that all kind of key together and can be replaced really easily by hand. You put it all back together. If you need to replace the auger and the basket, these are wear items that you do have to replace. Put it together. Move the second half of the machine back to the first half of the machine. Make sure the keys line up. Seal up the flange, and then you're ready to go. So it's a very simple maintenance to maintain these machines and keep them up and running. So did that help kind of visualize how the machine goes together and what the components are? Okay, cool. So the wear items there, you can imagine the basket and the auger. If you do have grit in your system and you don't have a real great grit removal up in the headworks, little background music. There we go. Cool, awesome. Thanks for your patience.
Do we have any more videos?
No, I don't think so. Not for this.
Sounds good.
Questions on animation, anything else so far? Everybody good?
Nope, we just use pressure and that auger to move it along, and it's really not designed to be a real intense washing action. We're just trying to physically remove those screenings out of that sludge. So, nope. Yep. Yeah, it's porous enough, and because it's under pressure, it just pushes that stuff out, and there's enough pressure that it cleans those holes out constantly as it pushes the liquid through. So. As I mentioned, the basket and those augers, those are the wear items within the machine. So if you don't have a great headworks, you start to get grit that accumulates in the sludge that you settle out in your primaries and secondaries. So if you do have a lot of grit that you're settling out into your sludge, that's like basically sand within that basket. So that does wear down over time, and you will have to replace the baskets. But if you have a pretty good grit system up front and you're taking out a lot of that real gritty stuff, those baskets should last easily 5 to 10 years before they need to be replaced. So, but yeah, everything else, the motor is sealed. You shouldn't need to replace that, and all the other components of it, like the cylinder-shaped press on the very end. You don't need to replace any of that stuff. It's all pretty durable and robust. So again, just a little bit of a recap here. It's a very simple machine and process. You literally just have a screw inside of a basket. But it is extremely effective and very proven. We've got over 1,000 of these installed worldwide, so they're very, very proven and not experimental by any means. Most plants are trying to remove the hairs and the fibers and the rags that might be floating down to the secondary process of your plant. Because of the pressure, you do get some natural cleaning of the screenings, but the screenings that do come out, if you were to look at them in person, they still look pretty dirty. But you do get the majority of the sludge out of there. The dewatering part at the very end, that's important to remove that water as much as you can so that you're not just filling up your dumpster with a liquid. And then again, we do have different bagging systems that can be utilized to contain the odors and the flies and mice and other sort of varmint that come into the plant with some of this pretty poor smelling stuff. This graph here, it doesn't really mean much to most people, but it just shows that as you increase your motor torque, which is essentially adding more and more pressure to that shaft on the inside, you can see the pressure increases on the inside of that shaft. So you squeeze those screenings more and more as you increase the motor torque and the motor speed. So it's very much a linear relationship here. So this is about 4 different pictures of the screenings that we're removing using the strain press here. So on the left, it's tough to see at the lighting here, but you can see there's some rags in there. That might be like a medical glove or something. This one right here, you can see there's a lot of fibers and longer rags and hairs. This is more fibrous hairs. And then up there, you can see that's more of like a scum screening that you would see from like a grease hauler, or maybe a grease truck that's dropping off cleanings from a restaurant or other type of grease areas. So yeah, a lot of really nasty stuff that you want to avoid putting into your pumps and valves and digesters. So here's what the baskets look like on the inside. We have 3 different sizes. We have a 3 millimeter, 5 millimeter, or depending on what you're screening, we can go all the way up to like an 8 millimeter. So we will help engineers and customers design which one is appropriate based on the sludge, based on the headworks they have, and what they're trying to remove and capture from that sludge. But for the most part, these are the most common sizes of the baskets that we see for our applications here. But as you can imagine, the smaller the screen, the more of the hair and the fibers you're going to be capturing and removing from that sludge. So the question that was brought up before is, what are the capacities of these? And every manufacturer has some different capacities that they rate their systems for. But in our case here, we have 2 different size units. We call it a 290, and then the other larger one we have is a 430. So the 290, we can do about 440 gallons per minute at 1% solids. As you go up in solids, you have to derate your machines. As you can imagine, if it's thicker, you just can't push as much through there because it just requires a slower screw velocity and pressure and torque. So when you go up to 2% solids, you have to derate that down to 375 gallons per minute. And, under the fog conditions, or maybe even post-digester where it's thicker and it's a little bit more of a thicker sludge, you can derate that even more down to like 150 to about 300 gallons per minute. On the larger size of things, we can get pretty close to 1,000 gallons per minute if you have 1% solids. And then we'll derate that down to about 800 or so at 2%. And then similar with the fats and oils and greases here, we'll derate that quite a bit, almost 50%, because of just the nature of that sludge that you're trying to squeeze out and trying to work with here. So those are the 2 sizes, but every manufacturer, they have different sizing depending on their testing and what they've proven over time. So again, maintenance-wise, these units can be maintained all by hand. So the 2 sections of the screws, these can be lifted by 1 or 2 guys, depending on the size of the machine. They break in half, so they're relatively easy. You don't have to have an overhead crane. You don't have to have a hoist or anything like that. But they have the caster wheels on the backside here. So here you can see they just pivoted this one out of the way. They don't even have to remove it and take it away from the other half of the machine. They can just pivot it over. But it's remarkable how easy it is to maintain these and to change out the baskets and the screws here. So. I mentioned that these are controlled pretty much autonomously by our VFD. So when it's measuring the two different pressure sensors on the front of the inlet and then the actual pressure in that chamber, which is being squeezed out, we can use the VFD to control the speed of that auger on the inside, and we can not only save energy, but really optimize that machine and make sure that it's working not too fast, but also not too slow where you're getting things that are backing up. So it's really important that that VFD is functional and that it's able to operate correctly based on those differential pressure measures and the measurements that we have here. So, and these are all provided as part of the system itself. So. Looks like we're having another issue again, maybe. I don't think I had another YouTube on there, but. Yeah. So the material of construction for these units, we build all of ours out of stainless steel. So we can do 304 or 316 stainless steel. That's not true of all manufacturers that are out there. Some people do painted steel, but we're big believers in doing stainless steel just for long-term durability.
So while we're fixing this here, historically Huber is known to be a European company. With the BABA requirement that came out a couple years ago, they actually bit the bullet and moved a majority of their manufacturing facility to the United States. So a lot of the equipment now is actually made in North Carolina. Correct me if I'm wrong. Mm-hmm. So that's a big advantage as well. A lot of the engineers nowadays are not going to specify equipment unless it meets BABA based on government funding. So Huber is now compliant with doing that.
Thanks.
That's a huge component, a huge, beneficial factor as well.
Yep. Yeah, so one of the questions that was brought up originally, which is a really good question, where do you stick these things, and do they do better at certain parts of the plant? And in reality, it depends on the plant and where the problems are. So I mentioned this a little bit earlier. If you do have problems and you have a kind of a poorly operating headworks facility, you might need these closer to the front after a primary clarifier. However, if you have a grinder and a lot of these screenings get kind of pushed downstream to after your activated sludge plant or maybe a secondary clarifier process, you can put these prior to your digester so that way you can capture any screenings or any sort of inorganics that are coming from all the areas of the plant that are getting pushed to that digester. So those are really common areas that we put them, although I would say the vast majority, probably 80% of the applications we put these in, they're right before everything goes into a digester. So as I mentioned also, if you're a bigger city and you accept sludge haulers that are doing grease trap cleanings and removals, a lot of times you want to screen those right before they get into the plant, just because you can remove a lot of the nasty stuff that comes out of restaurants. But that can be up at the headwork side of things as well. We're working on a couple of opportunities for those down in the Ohio, Kentucky area right now. Another kind of interesting location that we put these is on cruise ships. So cruise ships, a lot of people will flush things down toilets that they don't normally flush down because they don't want to put it in the garbage. So ships that have small wastewater treatment plants on the facility, or excuse me, on the ship itself, they will want to remove a lot of those screenings and kind of treat it as a bit of a headworks facility on board the ship. But that's what they look like, really small on a ship, and they take up very little room. So kind of a unique and cool application, but they seem to work really well for ships in order to help prevent these major problems from happening in their small little package wastewater plants that they have on board these ships. So here's some examples, and we've got, like I said, thousands of these worldwide, but these are just some kind of interesting facilities that we have across the country here. So San Diego, California, they were having some major problems with their digesters. They were accumulating like 10 to 15 feet of thickness of rags and fibers and nasty stuff that was accumulating in their digesters. And they were noticing that they were having to go in there very frequently with divers, to clean out those digesters. And as you can imagine, that's a huge volume, a big digester filled with 15 feet of rags and fibers. So they said, enough of this. We want to see if there's a way that we can intercept these rags and fibers before they go into the digesters. So we installed 6 of our screens, and they were 5mm screens for here. And we extended their interval that they have to go into those digesters and do a significant cleaning and removing of grit and other sort of things that are depositing in the bottom of those digesters by 3 times. So we're basically saving, or we're able to triple their cost savings compared to what they were spending before. In addition to cleaning out and saving money from removing those solids from the digesters, they also saw a major decrease in the amount of time they were spending on cleaning out clogged pumps and valves. So the operators had a ton of time freed up, and they were able to save a bunch of money as well. And then at this plant in particular, they were producing energy based off of the digester gases. And they noticed that when they no longer had the 10 to 15 feet of inorganics accumulating in those digesters, they had more sludge in those digesters producing more gas. So they produced more energy, and they were making even more money and saving more money because of the increased digester gas production. So there was multiple reasons why the strain press here saved them a ton of money and a ton of headaches. And again, they pretty much operate themselves other than the very small amount of maintenance every 5 to 10 years. So it wasn't like they were shifting maintenance from one machine to another or one area of the plant to the other. These are basically put on autopilot, and they run and they take care of a lot of the problems that they had. So pretty cool installation and pretty cool story of saving them a ton of money long term. This is down in Texas, so down at Fort Worth, there was a plant called Village Creek Water Reclamation Facility. They had a ton of scum that was being accumulated off of their primary clarifiers. So I don't know exactly what was going on, if they had a lot of industrial contribution that was coming into the plant that was giving them a lot of fog, but the digesters had a really thick scummy layer on the top of the primaries, and they were spending $400,000 per year just to get rid of that scum. So it's very costly, very much a headache for them to do this. They ended up buying a bunch of our screens with a 5mm perforation in that basket that I showed you. And now, instead of disposing all this and spending $400,000 per year, they're able to screen that, clean it up, and they can put it into their digester. And as a result, now they're producing more energy. They're actually making more money. So not only did we save them that money, but they're making more money just by generating more gas on site and producing more energy. So huge difference. They're extremely happy, and they sing the praises of these strain presses because of the problems that they eliminated on this facility. And as you can see, it's a quite large plant here. So yeah, as I mentioned, we can put this on the fog acceptance or like a sludge hauler acceptance that is doing grease trap removal. But really, on this type of application here, we recommend putting in like a 5mm basket. That over the years of testing and proving that we've done, we found that 5mm is generally the best size for screening that real sticky fog that you see from grease trap removal. The basket strainers that we see at some of the other facilities that are accepting this hauled waste from sludge applications, they have to go in there and they have to manually clean these things because they're, as you guys know, fog is generally real sticky and slimy, and it doesn't really get knocked off just kind of naturally through pressure. So they have to go in, they have to pressure wash things, they have to use warm water to get rid of that fog and get that to release. They're pretty frequently they'll plug up those screens and they will clog them and cause problems. And a lot of times the basket strainers that they have don't remove all of those inorganics that you're trying to remove. So yeah, you have a screen there and you have a basket to accept a lot of that fog that those haulers are bringing in, but you still have a lot of problems that are happening because of that. So our solution, you don't need to do that manual cleaning. It has enough pressure that it squeezes it through the holes and it keeps those holes open. It is designed not to clog at all. It just kind of pushes out the end once it's dewatered. And yeah, as long as you're using a 5mm basket, we found that it does remove the vast majority of the pretty nasty stuff that those restaurants and other industrial waste contributors will bring in. So yeah, this is what it looks like when you have those haulers bringing in the sludge that's got the pretty high content with fog in it. You'll take a lot of the stuff that's out of there and really clean it up. So this is another facility down in Greenville, South Carolina. This is their kind of an EQ basin that they have when the haulers bring in this nasty sludge here. So rather than putting that right into your headworks, you can remove a lot of the pretty problematic material right out of that EQ basin here. So this was specifically for fog screening. So the trucks that were coming in were hauling a lot of these grease trap contents, and they put it right into this big, basically basin to hold it and slowly put it into the plant. But they were also having major issues with kind of gumming things up in the plant, and insides of pipes were getting coated with a lot of fog and pretty nasty sticky stuff. So they wanted to run it through some kind of a screening mechanism that didn't require all the manual cleaning and maintenance, and the strain press is what they picked, and they were extremely happy with that as well. So one of the biggest things that they realized is that their old system had a system that needed a bunch of really hot water for a wash water, and with the strain press they didn't need to have that anymore, so it saved them a bunch of energy and a bunch of other maintenance for having hot water heaters and high pressure systems, and they were able to remove more material over their old system as well because we use a finer hole. So.
You guys kind of see the same common effect here is once they put these in, they end up actually saving money in various ways and also increasing their profits directly because of that as well. So it's an indirect positive effect. So it's more than what is the saying? 2 birds with one stone. It's kind of like 3 birds with one stone, you know? You put it in to do one thing and you end up getting 3 positive things because of it. So.
Yep. So like I mentioned, there's multiple other manufacturers that are out there. You can see here, this is a painted steel style sludge press or strain press. And this is the Huber one here, which is in all stainless steel, including all the internals. We use asynchronous motors as well, so we can slow them down real nicely, and we can tie that into the VFD to really dial in the correct energy usage as well as the pressure to apply to the screw. But with the asynchronous motors, we can save about 25% energy over other motors that are out there. So there's over the length of a system, the life of a system of 20 years or so, that 25% energy savings really adds up, and it's the higher quality way to go in terms of motors. All right, this is what a brand new system looks like. This is at a trade show here, but you can see where that break is on the middle of that machine. And yeah, generally the range is about 450 gallons per minute up to about 1,000 gallons per minute for the sludge screening. I'm sure you can't see this, but there's dimensions on these little drawings over here. And yeah, I apologize, it's a little tough to see, but
I don't know if you guys make it up to WEFTech or not, but if you guys make it to Chicago this year, definitely stop by Huber's booth. They have some pretty impressive demos and a pretty large space, so definitely stop by if you're there.
Yep, and we'll have probably this exact unit right here. I think that's a 290, but we'll have that in the booth if you want to take a look and get your hands on it and poke around. So I mentioned a couple times here, we have a bagging system that we can integrate into it if that's what you're looking for. And it's basically, it just kind of keeps pulling down that bag. And then once it gets to a certain point where the dumpster is full and you need to remove the dumpster, you just basically tie it off in the middle, cut it off, and then you start the next bag. So it's really containing this area from a lot of odors, and you're keeping flies away as much as you can, as well as mice and other varmint at the plant. So it's kind of a foolproof way to keep the odors down, and especially on those hot days where it can get pretty nasty out there at these plants. If you guys do have a interest in this and you want to give it a test before you make that investment and kind of take that big leap, we are big believers in piloting. So we have, I think we have 1 or 2 units that are constantly driving around the country. They're on a flatbed trailer, and we can pull it right up to the site. And we hook up basically two lines to this, your influent and your effluent, and we can run it right on the trailer as long as we have power and you run the sludge to it. And we can run it, our standard is a week. However, we can run it 2 or 3 weeks, depending on what the facility wants, but usually a single week is more than enough to demonstrate that you're getting good screenings removal. But this is what the pilot unit looks like here, and we can also lift this off of the trailer. So if you have an area where you want to stick it and run it, but you don't have maybe asphalt to pull the trailer up next to the building that you want, you can just take a forklift, move it over to the location and drop it down and run it, as long as you run the hoses up to it. So, but this is a very, very great way to demonstrate if it's going to work or not, or maybe you have a concern because you have an industrial customer in town that gives you some really funky stuff. We can pull this thing up and we can run it for you for a week or 2, no problem, and it usually does a pretty darn good job. So.
We'll actually be doing a demo next month just west of Champaign for about a week or 2. If anyone's interested in maybe stopping by to see that, it'd be a free opportunity for you guys to see it. If that's of interest, let us know. It's not too far from here. So
Yeah, I know I've kind of beat this horse to death here, but the real advantages here is for you guys. You are reducing your maintenance on your plant. You're reducing the headaches with clogged pumps and valves. You're improving your digester performance. You're doing less clean out of your digesters and clarifiers. And overall, it just really, really saves a lot of money and reduces headaches for operators. So I'm not saying this as a salesperson at all, but we are seeing an enormous amount of interest in these systems because they do really help so many plants and prevent a lot of these headaches from occurring at a lot of these wastewater plants. So there are very proven advantages here and pretty cool technologies to help improve the overall process and the quality of the sludge that you're producing from your wastewater plants. So.
we do have a pretty large installation base in this area as well, so don't take our word for it. If you want to hear somebody else talk about it, feel free. You know, I know us talking about it doesn't really do much for you. But yeah, feel free to reach out and talk to other people and get their firsthand opinion from it, you know. The proof is in the pudding is what I like to say, so.
And then just one last slide. I mentioned we've got thousands of these around the world, but we have these installed in over 40 countries worldwide. So again, very well proven and established technology, and tons here in the US and in North America. So yeah, sorry for all the technical difficulties here in the first half. Hopefully the second half will go a little bit smoother. But I think, yeah. Are there any last minute questions on the strain press before we bury this one? So in theory, you want to put these in a building up here in the upper Midwest, just because of those freezing risks and all the components. And the last thing you want on one of those kind of weird -10, -15 degree days is to get things to freeze up. So ideally, you will want them in a building to be heated in a climate-controlled environment. In terms of do you operate it 24/7, that's totally up to the plant and how much they're producing. And if you want to run it intermittently, we would recommend sizing up to a bigger unit that you run for maybe 8 hours a day as opposed to a smaller unit that you run 24 hours a day, or vice versa. So it depends on the plant and what their operator schedule is and how much they want to keep an eye on a machine. So we'll work with the engineer and with the city in order to figure out what is the most economical size machine to treat the screenings that they're looking to remove. So, but you don't have to operate it 24/7. It does take probably 45 minutes to develop that plug at the end where it's getting squeezed at the very last bit. But if you only are planning on running it maybe 2 or 3 days a week, you can run it for 2 or 3 days, and then we have a shutdown procedure where we squeeze out all of those screenings and we stop running flow to it. So it kind of cleans itself out, and then it'll sit idle for the remaining 4 days of the week until you start it up next Monday, and then it takes time to develop that plug, and then you just run it for 3 days. So you can do either 24/7 or intermittent, but we do have a shutdown and a startup procedure that it'll automatically do with the controls. So lots of good questions though. Any last minute questions before our break? Okay, cool. Yeah, we'll talk about sludge dewatering and thickening on the next slide here. So it's less removing inorganics, but it's more about squeezing water out and reducing the volume of our sludges. So feel free to use the restrooms, take a little break, and then we'll start going again in about 5 minutes or so. 10 minutes? Okay.
We're going to do jumping jacks until we get back.
I like that it has those wheels on it.
Yeah.
Stick it apart and all.
Yep. And we
You can check your mic off.
Yep.
Okay, I think we're ready. So every time somebody goes out to the bathroom, they have to wrap up.
Well, the problem is sometimes we get customers in here that are extremely loud right out there.
So complaining about their bill?
We don't want to hear any of that.
I noticed a bulletproof glass out there.
All right, welcome back to the show. Hope you guys enjoyed the commercial break. We'll do this one fairly quickly here, try to get you guys out of here in 45 minutes. This next presentation is going to be similar, but a little bit different. It's going to be on biosolids equipment. You'll see a lot of the concepts are very similar. The way it works is very similar. The end objective is very similar. So without further ado, I'll pass it back over to you.
Yeah, so the last presentation, it was all about removing stuff from the sludge. However, now, assuming that sludge is cleaned and it's either going to a digester or coming out of a digester, we are trying to remove water from the sludge this time. So we'll talk a little bit about the reasons why we're doing it, but I think there's a slide in here that I created a few weeks ago, and I think it's really effective, and it kind of shows you the reduction in the actual volume of the sludge as you remove more and more water from it through the different stages of the removal process. So on the surface, the idea of removing water from sludge, it makes sense, but I think when you see that volumetric change and improvement, I think it'll really hit everybody kind of right between the eyes. You can see how important it is to, and how much cost savings there are to remove that water from that sludge, so you're not just hauling a bunch of water out to fields, you're hauling actual sludge and saving a bunch of money.
So I'll ask the same question we did last time, is who's familiar with any kind of biosolid equipment, maybe running some now at their plant? Okay, got plans. Okay.
So yeah, again, feel free to interrupt me as we go through this here. So in your conventional plant, you have your headwork screening, you have your primary clarifier, some kind of a biological process or a secondary process depending on what you have going on. And then you have your secondary clarifier to remove as many solids out of that water as you can. And then it typically goes to either some kind of a filtration or a disinfection, UV or chlorine. Or now a lot of the plants across the Midwest are starting to look at some kind of a mechanical filtration like disc filters or sand filters. But again, when you're pulling your sludge off of your primary clarifier, secondary clarifiers, and it goes into your digester, this is the point that you're starting to want to try to reduce the volume of that sludge in order to squeeze out the water and just thicken it down to more of an actual sludge, so you're not having to move and treat all this additional water.
Can anybody tell me why you would want to do this? Why would you want to get this as dry as possible?
Yep.
Any other ideas?
It's a huge one.
That
Yep.
is correct.
Yep. Yep.
Okay.
Yep. Those are all. The main thing is, again, putting it in very, very simple terms. If you're trying to transport sludge that's at 2% solids, you might have to use 100 trucks worth of shipping the sludge out. But if you can reduce it down to maybe 25% solids through one of our presses, all of a sudden you're only using maybe 10 trucks or 15 trucks. So you're saving a ton of money when it comes to actual trucking costs or tipping costs that you might see with trying to move a lot of this thinner waste. So we'll dig into that here, and I think it'll make a lot more sense if you're not doing this at your plant, why there's a bit of a benefit here. So this is the outline, and I promise it truly is this simple. Is it time to look at sludge thickening, or is it time to look at sludge dewatering? And those two words, thickening and dewatering, they seem like they're kind of the same thing, but the way that they're actually doing the process is different, and we'll explain exactly what that is and the two different levels that we have that we can offer with our equipment. So thickening, typically you're taking solids and sludge off of your primary or secondary clarifiers, and you're trying to reduce that down. So typically it's coming in like between 1 and 2% solids, and the thickening process, you're trying to take it up to 5 to 6% solids. So again, 1 to 6 or 1 to 5, it doesn't seem like it's a huge jump in volume, but it really is a very remarkable difference between the two. Then the next step, which we call dewatering, this is where you're taking it from 3 to 6%, whether you're running it behind this unit over here, or it just naturally is that thick. You're taking it from 3 to 6%, and you're running it all the way up to 25% solids. So a much, much more thick. At that point, we consider it a cake. So it is a very thick, kind of a, I don't know, it almost looks like a compost. It's a very earthy, kind of a thick cake on the backside of there. But there's a big difference between that 1% all the way up to 25%, and we'll kind of demonstrate exactly what those volumes look like and the differences. So again, I'm trying not to be salesy here, but we do typically have 3 different stages of equipment styles in order to achieve different concentrations or thicknesses of our sludge. So on the lower end of things, we have a system called a disc thickener, and here we're adding a polymer to the sludge, and we'll explain what the polymer does, and most people know, but for those that don't, it basically takes the sludge, and there's a chemistry that happens, and it causes it to clump together into a flock, and then that flock tries to squeeze out water. So when you look at it, it actually looks like little, well, kind of gross, but brown snowballs that are floating around in that water, and the water can be removed relatively easily. So that S-disc is for thickening between that 1 and 6%. If you want to go higher than that, that's where we start to go into a press style of equipment, and that's where you're taking it from 3 to 5%, and you're squeezing it all the way up to 25% solids. And then in certain plants now, because of the PFAS problems that are happening and the interest in PFAS costs that are associated with trucking and disposing of these very harmful chemicals, if you can reduce your sludge down even more, rather than having to dispose of 20 truckloads of this PFAS-laden sludge, if you can reduce it down to 1 or 2 truckloads, it can save a ton of money over a 20 or 30-year life cycle. So we have a belt thermal dryer, which is using actual heat and air to dry it even more, up to 95%, which is a Class A biosolid. And we also have a solar dryer option if the room is available on site, where we can use the sun as well as fans and a mechanical turning device to dry those solids all the way up to a 95% concentration of solids. So you can see here from 1% all the way up to 95%. There's a massive range in the sludge concentration, but there are different technologies that can get you to whatever volume of sludge that you're trying to get to in order to save that money and reduce the plant. So first, we're going to talk about the S-disc model, which is on the very low end of things on the left, and this is typically to just get up to that 5 to 6%. Oh, sorry about that. So in our case here for Huber, there's different styles of this that are doing the exact same thing, just kind of different shapes and different volumes and flows. But what we have at the front of this, both of these units here, we have what's we call this a flocculation tank. We're adding a polymer to that sludge. We're turning it, we're mixing it, and we're trying to expose all that sludge to that polymer chemical where it binds together into a flock. It goes into the system here, and this is actually, it's not an optical illusion. This system is actually set at a bit of an angle. And that sludge goes into the this disc right here, and then gravity just kind of drops that water out through that mesh disc. And as that water drops out, it gets collected at the bottom, and it goes out and goes back to the front of the plant. The sludge that gets retained on the top of this mesh or the perforated plate screen right here makes its way around in a clockwise rotation here. And what's not shown, and you'll see in some future pictures here, is there's some actual plows in there, like you see on a conventional belt thickener, that squeezes it and pushes the sludge back and forth. And then on the back side, there's a bit of a kind of a guide that you can see, and it pushes that thickened sludge out into a hopper, which drops down either onto a conveyor or it might go to a digester. So that's called a disc thickener. We also have a drum thickener, which is, it almost acts like a concrete mixer. You have an angle and you're putting that sludge in there, and then that sludge is being squeezed against that basket and it gets turned upward towards the top, and then that water gets collected on the outside of the basket. It runs down, it gets collected down here, and it gets sent back to the front of the plant. So same thing, they're trying to get that sludge up to 4, 5, 6% solids concentration. Well, this clicker does not like me today. Oh, okay. So this is kind of boring chemistry stuff that most people, their eyes gloss over and it gets kind of boring. But what we're doing here on both of these systems is we're adding a polymer. And what that polymer does is it has a chemical charge that attracts it to the sludge that's in that water. So as it attracts itself to that sludge, it starts to form into a clump. And then those smaller clumps attract themselves to other smaller clumps, and they just kind of stack onto each other, and they eventually become a big flocked particle that is kind of afraid of water, and it kind of pushes water away, and it tries to just hang out with the other flocked particles. So on the chemistry side of things, you have a negative and a positive charge with the polymer and the sludge. They attract to each other, and they start to come together. So all of these systems that I'm talking about in the second half of the presentations today, they all use a polymer chemical to grab that sludge and kind of make it chemically bind together. We can also use metal salts as well, things like ferric and alum as well, but for the most part, polymer, we find it works better than those chemicals. So again, another picture here, we've got our negatively charged sludge, and we put in that polymer, which is positively charged, and it just kind of wants to bind them together and hold them together. If you don't use a polymer, you're basically just going to be pushing the sludge through these screens, and you're not going to be retaining much. It's still just going to stay a real liquid, kind of a homogeneous style of a liquid that you're pushing through. So the polymer is very key, and it's very critical to the operation of these screens. So here's some. Yeah, again, this is a very proven style of chemical addition to plants, and it's been around for decades and decades. So there's nothing really new or unique or fancy here, but this is a great photo of what it looks like when you add a polymer and you start to get those solids that all bind together and form into these flocked solids. And then the water, you can see, is kind of floating between, and it's being chemically kind of pushed away from the sludge, and it's much easier to remove from those solids, and it's much easier to dewater. So on a gravity belt thickener, these are really common in the industry. This is exactly what's happening in this flock tank right here prior to going onto the belt. You add that polymer, you mix it around, give it a little bit of gentle time to form together into these clumps, and then it's time to remove that. So that's exactly what we're doing here with our S-disc as well. We've got that flock tank up front with a couple of impellers that are slowly moving it around and causing those solids to bind together before you flop it out onto the S-disc surface there, where the water just drops out via gravity. Any questions on this stuff right here so far? Shouldn't be anything too new or groundbreaking here up to this point. Sorry about that. Okay, here we go. So for the gravity belt thickeners, typically they're using a real flexible belt, and it's just a long rectangular shape where it kind of falls out onto the belt on one end, and that belt is pushing it down along that surface. As it gets further and further down that belt, that water is dropping out through that belt via gravity down into usually a collection area. And then you have these plows, which are spaced every couple of feet or so, and they're pushing the sludge back and forth and squeezing it and trying to get that water to separate from those clumps. And that's exactly what we're doing also on the round S-disc shaped thickening process as well. However, instead of using a belt, which is rectangular shaped, we're basically taking that belt and turning that into a circular shape. So some of the benefits there are its smaller footprint. So it's usually like a 50 to 60% size reduction, same capacity. And then with the conventional gravity belt thickeners, they're usually elevated off the floor quite a bit. So you have platforms to go up on and work on them. A lot of times they're splashing around and they cause a lot of dripping and splashing in the area. Everything is contained within our S-disc here, so there's no splashing. And the collection system is very, very simple and contained. So it's much cleaner, much less humidity in the room, and it's overall a very, very, very contained unit. Here's what the bottom of the two different styles look like. You have at the bottom of the belt where that water is kind of dripping through here. And we use a perforated plate or a mesh, and you get a little bit of that dripping action, but it falls through much easier. And then we have a wash bar at the bottom of that to clean off any sort of solids that might kind of squeeze through. It just keeps it a little bit cleaner and less maintenance for the operators. Oh my gosh. Oh my gosh, this thing is. All right. So again, talking about square footage wise here, this is what you typically need for a gravity belt thickener, which again, these are very proven. These are very widely used in the industry. We just basically have a different style here and a different shape. If you need additional capacity and the single unit itself that we have doesn't have the capacity that you need, we can double them up using a single flock tank, and we call this a twin system. So you can get the capacity that you need just by simply adding another round unit there. But here you can see this is what the clearance is for maintenance and everything. It's about a 60% reduction, or a 30 to 40% reduction in overall footprint for an equivalent capacity system here. Okay, for the S-drum, this is a typical and similar process, but instead of using a wide disc, we can get increased capacity with an even smaller footprint. And here we're putting that sludge that you're adding that polymer in. It goes into this rotating inclined cylinder where you're squeezing those solids against that basket on the outside, and that water gets collected. And it gets collected down into that pipe, which runs down into the ground back to the headworks. And then those solids that get thickened to 5 or 6%, it goes up over the top into a hopper here. So I think Pekin, just south of here, has 2 of these installed. So they're using these, and they've been installed for about 15 years. But this is a great option if you have a really small footprint and you're trying to get a lot of capacity into the building that you have. So when you go to the next level up, so let's say you want to take your sludge up to maybe 18, 20, 22% solids. This is where we start to talk about dewatering, which is kind of that true next level step of removing water from sludge. So we call this a Q press. However, again, there's many manufacturers out there that offer similar machines. But our smaller unit right here is just kind of comes in this nice cylindrical style enclosure, which has a basket on the inside, all the way up to our largest units, which I believe East Peoria has 2 of our 800 units, and they look just like this. They kind of look a little bit more of like a substantial unit here. But this is what it looks like when you're starting to get up to that, approaching that 20% sludge concentration.
This is actually the unit that we're doing that pilot on I spoke about earlier is the Q press. I think it's actually not so compared to that side. So that's of interest to you, let me know the picture you guys can show there.
Okay, so this diagram here, this is what I was talking about at the beginning, one of the original slides that shows the volume reduction as you go across the technologies. So if you imagine you have 1,000 cubic feet of sludge at 1%, that's about the volume that it looks like right there at 1% solids. So you can see 99% of that sludge is water. If you run it through the S disc, which takes it up to 5 to 6%, that 1,000 cubic feet of sludge goes down to only 166 cubic feet of sludge. So there's almost a 10 times reduction in the amount of volume. So it's a huge amount of digester space you free up. The amount of trucks that you're using to haul your sludge goes down by 10 times. It's a massive cost savings. And this is typically the first step that we see engineers looking at and wastewater treatment plants looking at in order to reduce their hauling costs. So we're going to be talking about the dewatering step next, which is our Q-press, and that's taking it from 166 cubic feet down to 45 cubic feet. So you're reducing it by about 4 times, again, using this machine here. So originally you're going from 1,000 cubic feet down to 45 cubic feet. So huge reduction there in terms of the amount of volume of sludge that you're having to store or truck away from your facility. So this is what the dewatering press looks like here. Because you are now feeding this machine with 5 or 6% solids, you can no longer do that with a conventional pump. You have to use some kind of like a progressive cavity pump or some other type of pump that's designed for a thicker sludge movement. But from there, you pump it over to the machine. And this diagram here doesn't show a great job of it, but typically there is a flocculation pipe that we design into the machine. So rather than having a flocculation basin or a chamber prior to the machine, we will actually do it in about an 8-inch diameter pipe. So we'll inject the chemical with the sludge, and then you get a natural mixing that happens in that pipe. And then towards the very end of that, we start to slow it down, and we allow those flocked particles to come together and form a little bit more of a substantial flocked particle before we put it into the Q-press here. But then once it goes into the Q-press, I'll show you a couple slides here. We're no longer relying on gravity to settle that water out. We're actually applying a pressure using the screw like we did with the strain press in the previous presentation. And we now are physically pushing water out of the sludge and not just doing it via gravity. So in order to inject that polymer, we do have a sludge conditioning skid or a polymer control system, which will measure the flow that's coming in as well as the solids concentration, and that will inject the perfect amount of polymer in order to get to the amount of concentrated solids that you need to. The water that gets squeezed out will get collected on the bottom side of that inclined press, and then it'll get collected and sent out of the machine using a flanged 6-inch or 8-inch pipe at the bottom of the machine, depending on the flow. The cake that gets developed, that will be 20 to 25%, usually needs to be conveyed using an auger. So we're no longer using a pump to move that 20 to 25% cake. It has to be physically moved with an auger. And, that typically gets delivered with an auger to a truck, which is pretty common in most facilities. Oh my gosh. We'll skip that other slide. It's pretty similar to before. But basically, the piping system that I mentioned where we inject that polymer, you can see we inject it where that pipe is really skinny. So the flow is going through there at a pretty high velocity. And then when you widen that pipe, all of a sudden that flow slows down, and we give that polymer time to expose itself to the sludge and chemically bind on and then create a bit more of a flocculated sludge in that pipe. So that the sludge or the chemical goes down that pipe nice and slow, or this way I should say. And then at the very end, we have a couple of 90-degree elbows, and it goes into the machine here. And we try to minimize those 90-degree elbows because this gets pretty technical, but the 90-degree elbows introduce a bit of a shear velocity with the water, and we want to avoid having too much shear because we're trying to create particles that are clumping together. So we will work with the consultant and the customer to design this pipe diameter, the length, the retention time, how long that sludge actually spends in that pipe prior to going to the machine. And what's nice about this is you don't need another big tank on site to do the mixing and the chemical addition. It can be right in line as that sludge goes right to the machine. So it's a very small way of reducing the footprint of the overall machine and the ancillary equipment.
Is that pipe hollow?
It's filled with water, so yeah, it's a hollow stainless steel pipe. So it gets a little bit, I'm really sorry guys, this is very frustrating. That pipe, if you do have a footprint restriction and we can't get the right amount of mixing, we can design in a pipe that has like an inline mixer. But most of the time, if you have the footprint available, you don't need that, and it'll just be a solid pipe that's a little bit wider at that part. So, any other questions on the piping part of this here? I will go back. This, I didn't realize I skipped over the slide here, but this is kind of a cutaway diagram of what that Q press looks like. Again, this is going from 5% up to 25% solids. So your sludge is coming in here. There's a giant screw on the inside of that machine, which again is controlled by pressure differential with the controls. The outside of that screen, there's a wedge wire basket that has a pretty tight opening in order to retain the sludge particles and the flocked particles. Just like the strain press, that the inside of that auger starts out really, really tight, those flights on the inside. And then as the sludge gets thicker and thicker, the flights get wider and wider, and the speed of which the sludge is being pushed up to the front there reduces because you're taking a little bit longer to squeeze those solids in order to get the water out as much as you can. Then on the back end, we have another one of those pressure cones, which you probably recognize from the previous presentation. Same thing, it's a pneumatically pushed cone that's forming the end of that plug, and those solids will push out on the very end here, and they drop down into a hopper or a conveyor like you saw on the previous slide here. So the reason why ours are inclined as opposed to others on the market that are flat, if you're pushing a lot of water through here, and if you are trying to work too fast, water will accumulate in one of the machines that are flat, and the bottom 10 or 20% of the sludge will always be submerged in that water. With our machine, because it's up at an angle, that water is always running down and it's not accumulating on the inside of that cylinder. So we don't get that same re-wetting, which is a term that we use for water that kind of accumulates on the bottom of that. And it keeps the sludge drier, and you actually get a better performance at an angle. So there's a reason why it's set at that 20-degree angle or so. It's not just a marketing gimmick. On the end, we have our big motor, which is doing the turning of that giant auger. It does require quite a bit of torque to squeeze and to turn a lot of that sludge, especially once it gets up towards the end here when it gets real thick and kind of stubborn to squeeze out there. But yeah, that's basically the inside of what it looks like. We also have a washing mechanism, and you'll see on a future slide here, there's a bit of a diagram, but that wedge wire basket that's around that auger does need to be sprayed off in order to remove any solids that have kind of squeezed through and accumulated on there. So, but that's an automated system that will clean itself, and it will take care of that automatically. So you guys as operators don't have to go in there and do a giant pressure washing every week or so. So the sludge is going in on the one end of there. This is just another diagram of how it works. So the particles are coming together using that polymer. It goes through that press, and you can see this is what the cake looks like here at a 20 to 25% solids. So it truly is yeah, it's not a very good cake, yeah. But it definitely is pretty cool how thick it is. And again, this is 20 to 25% down here. And this is probably a good 25% where it's getting really granular and pretty dry. I'm honestly not sure. I'm not sure. We have our capacities. Just to give you guys an example, the throughput of these machines, our biggest unit, we can run about 150 gallons per minute. So if you imagine you're pushing 150 gallons through there in a minute, so it probably takes, I don't know, maybe 30 seconds from start to finish. It's not long. It's not like it's spending hours and hours in there. It's a pretty quick, but I don't know exactly how long. But the water coming out the back, it's very, very clean because, again, you've taken those flocked particles and it's chemically pushed the water away from those solids, and it's pretty easy to squeeze that water out, and it comes out pretty darn clean. That's what the wedge wire basket looks like here. It's kind of reinforced with some cross arms in order to, because there is a pressure in there, we have to reinforce it, and we have to make sure that it's strong enough to handle that pressure from the accumulating solids as well as the auger itself pushing against that. So the auger itself, this is what it looks like. It's a very constantly changing diameter auger. So unlike the strain press where it changes over half and then it's consistent for the second half, our auger, because you're constantly getting thicker and thicker and thicker and thicker throughout the entire length of that device, it does change over the entire distance from start to finish. The auger itself, it does have a wear bar on here, so that's always very, very tight against that screen in order to keep those solids pressing upward. That is a wear item that has to be replaced from time to time because you do have a lot of pressure and a lot of friction against that. However, it is relatively easy to replace, so I shouldn't do this, but I'm going to run into problems again, I'm sure. But if you remember that previous slide, there's actual components of that basket that will be lifted off so you can get access to those wear bars without having to really take the whole machine apart. It's designed to be very user-friendly. This is a bit of a cutaway here of what the wash system looks like, which is all automated. So it's a high-pressure washing system, and it will rotate around that basket on the outside. It'll go back and forth to do the pressure washing, so you guys as operators don't have to go in there and do that. And that happens on a regular basis, whether it's once a week, depending on the frequency of how often it runs, maybe once a day if you guys are running these things for 24/7. But these will automatically run based on the controls when it's needed and based on how many hours that it's been running. All right. Yeah. So these are the considerations that we take into account when we're designing these systems here. So flocculation, we want to make sure that this is hypercritical. We want to make sure that this pipe is designed correctly, because if you can't get the chemical to react with that sludge properly, you could put that sludge in there all day long and you're only going to get maybe 10% solids because you don't have the right amount of time, you don't have the right amount of chemical, you have maybe too much turbulence that's going to shear those particles. So the flocculation stage prior to that sludge going into that screen itself is extremely important, and we spend hours and hours working with the consultant to make sure that that's dialed in just right. Without that, it's just basically an expensive paperweight. The cake discharge, we want to make sure that we balance the amount of chemical usage with what the actual target is for discharge. So I was actually talking to Jeremiah, who's the operator for East Peoria, and he has 2 of these Q presses installed, and he said that I asked him what level of sludge they were getting to, what concentration they were getting to, and was there chemical usage balance and everything. And he said we actually found that in their case, in order to go from like 22% up to 25%, it required a ton more polymer. So polymer equals cost. So he found that it was actually more costly to use more chemical to get that little bit more additional thickness of that sludge. So he said we are fine just running it at like 20, 22% because it saves him a bunch of money and using all this extra chemical just to get a very small amount of improvement. So we will work with you. We can do bench sampling at our facility down in North Carolina. We can do piloting to figure out exactly where you need to be and how much chemical you need to use based on your sludge at your facility. But in terms of the actual cake target at the end of the facility and at the end of the Q press itself, we can work with your consultant or with you guys to dial in exactly where you want to be with the cost, the size of the machine, and the end goal in order to design it just right for what you need. For the spray wash water, that's really easy. We just need to know the size of the machine and how frequently it's going to run, and we can calculate how much clean water or non-potable water you need in order to run your wash water system. The filtrate, what do we do with that water when it gets squeezed out of that sludge? Does it go back to the headworks of the plant? Does it go back to a secondary clarifier to get cleaned up a little bit more to remove any sort of solids? We'll work with the consultant on that. And then the controls, we have very standard controls for our machines. However, we can customize the heck out of it. So if you want to take this machine and you want it to run 100% autonomously, so We could absolutely do that. It costs a little bit more, but you can tie it into SCADA. You can watch it on your phone. You can turn it on and off from your phone. Guys can watch it on the weekends when they're at home. It's pretty cool what we can do to automate these and make it as autonomous as possible. In the past, this style of sludge thickening and dewatering has been very much a task that you assign an operator to sit there and babysit it every day, 3 days a week for 8 hours a day. What we find is the biggest struggle, honestly, is changing superintendents and operators' mindsets into thinking you don't need to have Bill go sit there and watch it Mondays and Wednesdays and Fridays for 8 hours a day. You can turn this thing on, you can monitor it from your phone, and if there's an error or a fault or something, it'll give you a notification on your phone, and then you can go and address it. And it's smart enough that it should shut itself down as long as there's the correct signals and it's talking correctly to your SCADA system. So the level of automation and controls can really be dialed in to create a very hands-off system as much as you want, if you want to go that route. The other things that we take into account when we design these are, do you have the clearances around the machine to maintain it? They're usually pretty easy to maintain. You just take these hatches off and you can work on it from the top. But we want to make sure it's going to fit in the building and you're going to have the room to work on it and move around it. Similarly, is there enough access room for inspections and making sure that you can operate and work on different components of it without having to kind of squeeze against a wall and be cursing us for the way that we designed it in the future. And then lastly, points that need different lubrications like bearings. Can you get to those pretty easily? And like here's an example. I'm not sure if there is anything that needs to be maintained up here. Can they get around this railing? Can they really get up there and work on it? And we try to take those things into consideration when we're working with a consultant on either a new building or modifying an existing building. Any questions on this stuff or the kind of the pre-design work that we do in order to work with the facilities? It's pretty straightforward. Yep. Yeah, I think we're messing around quite a bit with that, so we'll just kind of skip that. But Eddie. They sound the same and they kind of mean the same thing, but they really are a dramatic difference between what your end goals are and what you're trying to accomplish. So. Yep. Yeah. Yep. Both. Yeah. So we have people that are around the country all the time. We have a whole service group that not only do they do regular maintenance when we have maintenance contracts with customers, but they also do on-the-spot maintenance where maybe you have something that's broken and you need help fixing it. We can send people out to the site, and we also partner with our reps as well for that. So we have. I don't know exactly where they're located here in the Midwest, but I think we have 1 or 2 guys that are here in the Midwest that typically cover the upper Midwest, but east of the Mississippi River. So we can usually get people to site within a week, a worst case scenario, 2 weeks. And if we start to run into problems where our guys are just totally jammed up, that's where we start to partner up with our reps because they have people that are right here in the state that can go around and get there within a day and maybe 2 days, but yeah, they're much more locally able to jump to wherever they need to be. So, and then these machines, these are really common machines for us. So we have tons of spare parts and the pieces that you typically need to replace, like the baskets or the augers. We have spare parts like crazy down in North Carolina that we can ship out and get to the locations pretty quickly. think one of the, yeah.
I just have a question, maybe not for you two, but for the rest of you. Like, what is everyone using for polymer cleanup? Like for parts and polymer pipes, polymer skids, is some sort of a chemical being done or cleaner that works?
I can't think of the name of it.
Do you have something, Brian? You could always email me.
Like if you have a little polymer spill on the floor or something on the
Yeah,
machine.
or like if you're, sometimes we have parts that have been exposed to polymer that we want to clean up. You know how it gets real snotty and you can't clean it with water.
So, water's the last thing. Don't ever put water on it. Yeah, we have. I'll look at the name of it. We have a couple products.
If it's on the floor, we use oil dryer.
Yeah.
Is what we use. And usually, you'll have that dust float for a couple days and it starts to wear off. And you're good to go.
Yeah, if you can let it dry on the floor, then it'll just scrape off.
Ours does not do that.
Huh.
Ours turns into like a small, even with a scraper, it's, you know, the stuff that you put on mailing labels? It's kind of like that.
Yeah.
It's just still a little gummy and tacky.
Well, I'll look at it, find the name, email you.
You got anything, Nick?
Yeah, I think one of the biggest drivers and considerations for this, other than just the volume reduction, is it seems like the EPAs and DNRs and all the other regulating agencies around the country are getting more and more interested in PFAS. And if you're able to reduce your sludge volumes down to a much smaller amount, I think there's less risk associated with how much cost there is to dispose of the PFAS-laden sludge. And it seems like that's really the reason why we're getting a lot of these requests. Are plants are worried that instead of having to deal with 20 million gallons of this sludge, which is probably got PFAS in it, if they can reduce it down to maybe 3 million or 2 million gallons of sludge, it's less risk and less liability, less cost for them to dispose of this. But I know there's a ton of unknowns out there on what's happening with PFAS, and is it going to be regulated? Is it just kind of a scare tactic right now until they figure things out? But that seems to be a driver, just kind of full disclosure to everybody, that seems to be a driver to reducing the volume of sludge that you have on site using thickening and dewatering. So.
You didn't really cover your dryers. What's your dryer footprints?
So we do have a pretty broad range of sizes. So we can they're pretty modular, so you can make them larger and larger and larger. But it's kind of a tough question to answer depending on how dry you need to get. Do you need to get to Class A? Because then you start to talk about how long it's exposed to heat. So it's kind of a loaded.
Set size. Like, is it one module is 20 feet, the same, or is it a custom module based on the application?
It's
Stackable module kind of thing?
pretty much, yeah. So
Is one module?
they're, I don't know the exact dimensions, but I would estimate it probably like 20 feet wide by anywhere from 40 to 80 feet long, roughly. It all depends on ancillary equipment and how long it needs to be cooked in that dryer. But
I guess each unit got a throughput, percent reduction.
Yep.
How you size it.
Yep. Yeah, and I didn't cover that on here because not a ton of people are looking at dryers yet, but there are some. We do have some installations here in the Midwest. Up in Wisconsin, we have 2 or 3 big ones at La Crosse, Sheboygan, some bigger communities up there, 50,000 people communities. Yeah. But yeah, if you are working on a project or you're considering looking at that, we'd be more than happy to talk a little bit more detail with you after. So. Any last minute questions?
If you guys think of questions or anything after the fact, you guys don't have my information, I have some cards over here. Feel free to call me, text me, whatever you guys need. I can help whenever I can. Otherwise, I appreciate you guys letting us come in. I really do. Hope you guys have a good rest of the day. I know it's Friday. Weather's nice, you know. Like I said, if I can help with anything, please let me know. If it's regarding this, anything else, whatever.
Thank you very much.